What we're talking about today is matter classification. So we're taking all of matter, all the different things that we can think of. Matter includes you, your desk, your pencil, the air you breathe, pretty much everything. And we're going to try to put that stuff into categories. So we're classifying it by what it's made of, how it's constructed, whether it's an element or a compound. Probably a lot of the words that we're going to talk about will be familiar to you, hopefully, from junior high. And we're just going to review all of those things that we should already know. Starting out with a definition though, chemistry is, and I think maybe we had this in our previous set of notes last time. Chemistry is the study of how and why stuff appears and behaves as it does. So this is definitely a review from our last section. And I think I told you in the last set of notes, this is the definition that my high school chemistry teacher gave to me. And I think it does a really good job of explaining what we do and what we look at. How and why stuff appears and behaves as it does. But what we're going to talk about today is, what is that stuff? What are we looking at? What are we studying? So stuff means matter. And matter is anything that has mass and volume. Sometimes you hear anything that has mass and takes up space. You, your desk, your pencil, the air you breathe, all of that is made from matter. Hopefully you remember from a previous class that volume is how much space something takes up. Does anyone remember what mass is? It's almost the weight of something. It's very close to saying the weight of something. And in fact, when I told you to take the mass of the Skittles, I used that word interchangeably with take the Skittles, put them on the balance, and weigh them. There is a small difference between mass and weight. Mass is a measure of how difficult it is to change the object's state of motion. So even though in our everyday speech we might interchange the words mass and weight, what we're actually going to be using in class are masses. And it measures how difficult it is to change the object's state of motion. The picture here is a quick example of that definition. If you have a semi and a car and both of them need to come to a sudden stop, which one is harder to stop or it's going to take longer to stop? The semi, because it's more massive. It's going to take more to change the semi's state of motion than it is to change the car, because the semi has more mass. Real quick, weight is something we're going to talk about if you take physics next year, and that has to do with the addition of gravity to the equation. So you're looking at something's mass, but you're also taking into account what planet are you on when you're measuring that object's mass. So weight includes gravity and mass does not. Okay, so here we go with the classifying. The first thing we're going to do is take matter and break it down into two main categories. So the first step of classification we have is two categories. The first one would be called a pure substance. A pure substance is made of only one kind of atom or molecule. What's the pure substance in the picture? Gold. Gold is an element, and you find it on the periodic table. In fact, anything that you find on the periodic table would qualify for a pure substance. It's made of only one kind of atom. But another kind of pure substance is made of one kind of molecule. Water is a pure substance. As long as you're only talking about water, And you're not talking about all the things that you find in your water, like fluoride and minerals and all sorts of those things that you get with tap water. If you're just doing or talking about pure water, like distilled water, that would be a pure substance because every molecule in that container would be an H2O molecule. Here's another example. Carbon dioxide is a pure substance. It's one kind of molecule. And this tends to confuse students sometimes because you look at that chemical formula that you see there and you say, okay, CO2, there's two things there. There's carbon and there's oxygen, but they're bonded together into a molecule. So one kind of molecule can be a pure substance, one kind of atom is a pure substance. The other main category for the classification of matter then would be things that are more than one substance. So those would be known as mixtures. Two or more pure substances that are physically mixed together. A rule of thumb for how to tell the difference is that you cannot represent a mixture with a chemical formula. There's too many things in it. You would need a list of chemical formulas for a mixture. What's the picture supposed to be an example of? Apple juice. Can you write a chemical formula for apple juice?
Sure.
You could write a list of them. Can you pick one or two elements off the periodic table and say that's apple juice? No, because there's too many things in it. Apple juice is a mixture. Other mixtures include things like chicken soup. Chex Mix is one of my favorite examples because you can actually see the pieces. You can tell that it's a mixture. You can tell that it's different pieces. Chicken soup would be the same way. You usually have pieces of chicken and noodles and maybe vegetables and the broth. It's obviously more than one thing. So the first step that we took was we started with matter and we separated that into two categories, pure substance or mixture. The next thing we're going to do is take each of those categories and break them down even further. So pure substances can be classified by what they are made of. Pure substances can be further classified or put into smaller categories by what they are made of. Pure substances are either made of compounds or they're made of elements. Compounds or elements. A compound is something that is made of molecules. A molecule is a unit of different type of atoms that have been bonded together, like a molecule of water. A molecule of water always has two hydrogens and one oxygen bonded together. If you put a whole bunch of water molecules together, that's a compound. Elements, then, are made of only one kind of atom. There's a very limited number of elements. They are all found on the periodic table. If you can't find it on the periodic table, then it's not an element. Have you guys noticed that there's a periodic table on the back of your notes packet? Check and see, make sure I copied it right, but there should be one there. Yep. So if you need one as you're going through your homework, either tonight or in the future, you do have one. There's also one in your planner. You also have a tablet, which could access several different kinds of periodic tables if you wanted. So pure substances are either compounds or elements. But what are compounds? Compounds are things that are made of molecules. A molecule is a group of atoms that's bonded together. It has a chemical formula. An example would be water, H2O. We had this example earlier too. Carbon dioxide is CO2. Carbon dioxide is one of the things that your car gives off. Highly suspected as being one of the major causes of global warming. We are making too much carbon dioxide. Its close cousin is also a compound. Carbon monoxide might be one thing that you've also heard of. Yeah, it can kill you. In fact, it's a good idea, and I have one in my house, a carbon monoxide detector. What in your house might put off carbon monoxide if it needs work or it's broken? Yeah. I don't think your stove does carbon monoxide. It might, but your stove is mostly methane. It's mostly natural gas. Usually, the main culprit that I've heard of is furnaces. If they're needing work or something's broken in them, is a furnace that puts off carbon monoxide. Carbon monoxide is one of those things that you can't smell, you can't taste. So there's no way to know that it's in your house except having a detector. Interesting fact though, my husband put our detector in the wrong spot. Carbon monoxide is heavier than air. So if it is in your house, where's it gonna be? In the basement or at least on the floor. Where's your smoke detector? Up high. Where did my husband put the carbon monoxide detector? Right next to the smoke detector. I keep telling him that he's gonna have to move it one of these days because it really should be along the baseboard. Anyway, next one, elements. Remember, pure substances are made of either compounds or elements. Hopefully you could give me several examples of elements. I just picked a handful to put up here. Oxygen, of course, is needed for breathing. Hydrogen is the simplest element that exists. Copper is a metal that we're all familiar with from pipes and pennies. Iron, another metal that we're all familiar with from cars and structures and ironing. It's an iron. First hour chemistry is so rough. Magnesium, tin, here are some other examples. Tin used to be used to make tin cans, not so much anymore. They're mostly made of aluminum now. And we could go on because there are several elements on the periodic table. We could list them all if we wanted. That would take a long time. A couple of side notes about elements. Here are a few things you should know. Side notes about elements. Symbols for elements always start with a capital letter. Please make sure your capital letters look like capital letters. Be very careful with the letters that look the same, both capital and little, like a C. Make sure your capital letters are bigger than the rest of your letters. If the symbol is more than one letter long, then the rest of the letters are lowercase, and they do need to look like lowercase letters. I will start to take off points for that if I see you writing two capital letters in a row. The reason we do this is to avoid confusion, because these two things look the same if you're not careful with your capital letters. The element cobalt has a capital C and a little o. The molecule carbon monoxide has a capital C and a capital O. Those are two things that are very different from each other. Cobalt is a metal. Sometimes compounds of cobalt are used to make pigments. It's a really pretty dark blue color, cobalt blue. Sometimes you hear it used to describe like ceramics or glass, cobalt blue. Carbon monoxide is a gas that we just talked about. It can kill you if it's in your house. Those two things are totally different. And we need to make sure that we note that difference when we write the symbols down so that we don't get them confused. Okay, back to the other branch of the matter family tree. We started with matter. We broke it down into either substances or mixtures. Then we looked at substances, and we said substances are either compounds or elements. Compounds are made of molecules, elements are made of atoms. Now we have to go back to the other side and do the other branch of the family tree. There are two kinds of mixtures. Heterogeneous mixtures are the first kind. These mixtures are ones in which the substances are not evenly distributed throughout the mixture. Not evenly distributed. That means that not all parts of the mixture are exactly the same. Individual components remain physically separated and can often be seen as separate things. Of the mixture examples we used before, Chex Mix and chicken soup are perfect examples of this. You can see the individual pieces. Those pieces remain physically separated. Think about Chex Mix. You could pick out the pieces that you want to eat first, and then all the rejects are in the bottom of the bag at the end. The individual components remain physically separated and can often be seen as separate things. A good rule of thumb for a heterogeneous mixture is anything that has to be shaken or stirred before you use it is a heterogeneous mixture. If you have to remix the contents before you want to use it, that mixture has remained separated and you have to mix it back up. Examples. Salad dressing, the kind that has 2 layers in the bottle, oil and vinegar salad dressing, you're supposed to shake it before you put it on your salad. What's the picture of? Paint. Why do you have to stir paint before you use it? It's not too thick. It has to do with the color, with the pigments that are in it. If you don't stir paint before you use it, you'll get an uneven color when you paint your walls with it. Milk is another one. And this one's a little bit surprising sometimes, but when milk is on this list, we're talking about like whole milk, straight from the cow. One of the things that the dairy industry does is when they process the milk, they homogenize it. Homogenized milk, you might have seen that on a carton or on a milk jug. And in order to homogenize it, then they do take some of the fat out and they separate the milk into the grades that you're used to seeing, like 1%, skim, 2%. Whole milk, straight from the cow, is a heterogeneous mixture. Have you heard the phrase that the cream rises? The cream of the crop, the cream rises to the top? No. It's probably falling out of use because most people don't have their own milk cow anymore, but when you got milk straight from a cow, if you would let it sit in the bucket, you would find that all of the cream, or the part with the highest fat content, would rise to the top of the bucket. So the cream rises to the top. That's where that phrase came from. Toothpaste is another one. You can think about toothpaste as the kind with like stripes or a little sparkly green or blue bits in it. But if you even just take plain white toothpaste and you take a little bit and you rub it between your fingers, it should feel slightly gritty. They put a little bit of an abrasive in there. It's usually calcium carbonate, I believe, comes from seashells, things like chalk. But it helps to have a little bit of an abrasive to clean your teeth with. If you use the gel toothpaste though, all the plain blue and the plain green, you won't feel that because it's not the same makeup. Chex Mix, of course, is my favorite example for a heterogeneous mixture because it meets the qualifications so well. Okay, the other kind of mixture would be homogeneous then. A homogeneous mixture has substances that are uniformly distributed throughout the mixture. Uniformly distributed. That means that all parts of the mixture are exactly the same. Sometimes I use the example of pop or Kool-Aid for this, because if you take a drink from the top of the container and the bottom of the container, it should taste exactly the same. So all parts of the mixture are exactly the same. These mixtures are not the kind that settle out. Homogeneous mixtures will not settle out over time. This is because they are mixed on the molecular or the atomic level. Instead of just having something that is physically stirred together, like chicken soup or Chex Mix, these mixtures are mixed on the molecular level. Their atoms, their molecules have been mixed together. Homogeneous mixtures. Side note for vocab. They are also known as solutions. Solutions are always made of two parts or two components. The first one is called the solvent. The solvent is the material that does the dissolving, and it's present in greater amounts. Water is known as the universal solvent because it dissolves most things. A solvent is what does the dissolving. The other part is called the solute. That's the material that is being dissolved, present in lesser amounts. I usually use the example of making Kool-Aid. If you're making Kool-Aid, the water is the solvent and the powder is the solute. And last, we have some examples of homogeneous mixtures. Kool-Aid, of course. Antifreeze is another one. It's ethylene, glycol, and a few other things. Pop is one that we are all pretty familiar with. Air is one that you might not have thought of. But as long as you're not talking about pollution in one area or another, do you ever find yourself walking down the hall and suddenly there's a patch with no oxygen in it? That'd be pretty funny, but no, that doesn't happen. Air is homogeneous. It's mixed on the atomic level or on the molecular level. Nickels are another one. Sometimes people don't realize nickels are what's called an alloy. So it's made of more than one metal mixed together. It's not pure nickel. All right, that brings us to the end of our matter family tree. Questions? No. Okay, there is a worksheet to pick up. Make sure you get that. I think the bell's going to ring in just a second. Thank you for being a wonderful studio audience today.